So here we have a quadratic equation. So it's y is equal to negative x squared plus x plus 6. Now the roots of this quadratic equation are just whatever x values uh, obtain whenever y is equal to 0. So when y is equal to 0, as the points on this slope where there are the red circles, all right, that's where y is equal to 0 on this slope. And we're wondering what those x values are whenever y is equal to 0. Now we can see that those x values in this case are going to be negative 2 and positive 3. So the roots for this equation are just going to be when x is equal to negative 2 or when x is equal to 3. Now here we're using the graphing method to figure out what the roots of this quadratic equation are. We're not always going to have the ability to just look at a graph, and sometimes even if we did, it wouldn't be necessarily clear what the roots are. These are integers, but sometimes it'll be, something like x when x is equal to 2.13 or something like that. Now, what are the usefulness of roots? Well, they tell you, for example, when the height of a firework is 0, or when in other contexts, maybe when the velocity of the firework is 0, or when the acceleration of the firework is 0. So roots are actually used by physicists all the time to try and figure out how much power they need to give, say, to a rocket so that it can escape the Earth's atmosphere before its velocity gets to 0. And they'll use roots to figure out when that velocity will get to 0 for that rocket. Now, even though we can't always use graphing to help us find out what the roots are, the factoring methods that we actually went over in our last unit are actually really helpful here in trying to figure out what the roots of a quadratic equation are. So for example, if you have y is equal to x squared minus x minus 6, well, we learned that we can factor x squared minus x minus 6 in a particular way. Right? So we're going to set that equation equal to 0, then we're going to factor it, and that's going to factor in x minus 3 times x plus 2. Because remember, negative 3 times positive 2 is equal to negative 6, and negative 3 times positive, or negative 3 plus positive 2 is equal to negative 1. And in that equation where it says x squared minus x, the implicit coefficient there before that x is a negative 1. It's x squared minus 1x minus 6. Negative 3 plus 2 is equal to negative 1. So they add up to that coefficient properly. Now, if x squared minus x minus 6 can be factored in this way, well, then we know clearly what the roots are going to be in order to make this equation equal to 0. All right, it's going to be when x is equal to positive 3 and when x is equal to negative 2. And we can see that. So if we just replace each x with a positive 3, then that becomes 0 is equal to 3 minus 3 times 3 plus 2. That simplifies to 0 is equal to 0 times 5. Right, and 0 times 5 is equal to 0. So that is a proper equation. Now, if we had, instead of plugging in positive 3, if we had plugged in negative 2, and you can work this out for yourself, we would still get the equation equaling 0. So our roots for this equation are going to be negative 2 and positive 3. Now, just for a little bit of a review, sometimes we have to use that slip and slide method. So on this new equation, 0 is equal to 2x squared minus x minus 6. There's no greatest common factor to take out right now, but that number in front of x squared isn't 1. All right, it's some other number. In this case, it's 2, and so that means we have to use the slip and slide method. And so our first step with the slip and slide method is going to be multiplying that 2 to the 6 in the back. All right, and now we just go and use our normal factoring method like we just did to the left, we'll get 0 is equal to x minus 4 times x plus 3. Now we can't forget about that 2 that we multiplied to the back to begin with, so we're going to now take that into account. So now we have x minus 4 divided by 2 times x plus 3 divided by 2. Now that 4 divided by 2 is going to simplify to 2, so that's not going to be a problem. The 3 divided by 2 cannot be further simplified, and so we're going to bring that 2 in front of the x in that parenthetical. All right, so we're going to get 0 is equal to x minus 2 times 2x plus 3. So what are our roots going to be here? Well, the obvious one is going to be that one of the roots is going to be when x is equal to positive 2, because that would make that first parenthetical equal to 2 minus 2, which is 0. And that'll make the whole thing equal to 0. To figure out what the other root is going to be, we're just going to take that 2x plus 3 in the second parenthetical, and we're going to set that equal to 0. And so subtract 3 on both sides. Divide both sides by 2. And we get that second root, which is x is equal to negative 3 over 2. All right, and we can see this if we plug that back into what we originally had. 2 times negative 3 over 2. In that case, the 2's are going to cancel each other out. And so you're just going to have negative 3 plus positive 3, and that is equal to 0. All right, so in other words, if we plug in negative 3 over 2 for the x value in that second parenthetical, that's going to make that second parenthetical equal to 0. So our two roots in this case are going to be negative 3 over 2 and positive 2. I should note that even just taking a greatest common factor itself can also help us to determine roots. So here we have a function where y is equal to 4x squared minus 24x. Now, again, when we're finding roots, we're trying to find out what x is equal to whenever y is equal to 0. Now, when we take out our greatest common factor from these two terms, we've got to find out which factors go into both. So in this case, 4x squared and 24x both contain a 4x in them. Now, what is left of each of these two terms after we've divided out a 4x? So what's left in 4x squared after we've divided out a 4x? That's just going to be x. And what's left of 24x after we've divided out a 4x, and that's just going to be 6. So we've extracted the greatest common factor, and now it's actually really easy to see which values of x will result in a y value of 0. So in the first case, we know that y will be 0 if x is equal to 0 also. So let's see how this works out. If x is equal to 0, then y is going to be equal to 4 times 0 times 0 minus 6, which is ultimately just going to be y is equal to 0 times negative 6. And 0 times anything is 0. So if x is equal to 0, then y is equal to 0. Similarly, if x is equal to 6, y is also going to be equal to 0. So when we go through the same process where we plugged in a 6 for each x value, it's ultimately going to boil down to y being equal to 24 times 6 minus 6, which is 0. So we have 24 times 0, and 0 times anything is 0, so y in this case will also be 0 whenever x is equal to 6. And so that means our roots are going to be 0 and 6. And we can verify this if we look at a graph of the equation of y equals to 4x squared minus 24x. So here is a graph of that, and we can see that whenever x is equal to 0 and 6, it's at those two specific points when the line is going through the x-axis. And at the x-axis, the value of y is always 0. Now, on the second page of your current packet, it tells you how you can solve quadratics by square roots. And what it means by solving a quadratic is just being able to find the roots of that quadratic equation. So you can use the square roots method to find the roots of a quadratic equation whenever the equation is of the form ax squared plus c is equal to 0. In other words, whenever there is only an x squared and not an x to the first power. So for example, let's say we have 7x squared plus 8 is equal to 15. Now this may not look like it fits the form ax squared plus c is equal to 0, but a simple rearrangement can make it fit that form. So all I did was subtract 15 from both sides. 15 minus 15 is 0, and 8 minus 15 is negative 7. I'm not going to subtract 15 from 7x squared because they aren't like terms. In order for them to be like terms, they would have to have the same variable to the same power, and 15 doesn't even have an x as a part of it, so I can't subtract it from 7x squared, just from the positive 8. Okay, so we have it now in that form. Ax squared plus c is equal to 0. Now what are our steps? Now your notes page on the second page of your packet does give you the 3 steps, which I'll now go over. The first step, isolate x squared. So what's the first thing we're going to do? I'm going to add 7 to both sides so that we now have 7x squared is equal to positive 7. And then I'm just going to divide both sides by 7 afterwards to get us x squared is equal to 1. Now, after I've isolated x squared, I'm going to go to step 2, take the square root of both sides. So I've made another video that's on Canvas showing you how to take square roots. So I'm going to just take that for granted at this point. So we're going to take square roots of both sides. So what's the square root of x squared, and what's the square root of 1? Well, the square root of x squared is just x. The square root of 1, well, 1 times 1 is 1, so the square root of 1 is just 1. Now don't forget that when it comes to taking square roots, it can always be either positive or negative, because when you multiply two negative numbers together, the negatives cancel each other out and result in a positive number. So negative 1 times negative 1 is also equal to positive 1. So the square root of positive 1 is going to be both positive 1 and negative 1. Step 3, simplify the radical, place plus or minus to indicate both answers. There's no further simplification here. We're going to go into that on another example in a second. But I again just want to show you guys a graph of what this equation, which I just made it y is equal to 7x squared minus 7. So I plotted that on Desmos. And when I did that, we can see that the roots, or where the slope intersects with the x-axis, where y is equal to 0, is both when x is equal to negative 1 and when x is equal to positive 1, which were the roots that we solved for in step 2. So the roots here are going to be plus or minus 1. So I should say that the problem that I just solved on the last slide was problem 2 from the second page of your packet. Problem 2, and I'm now going to solve problem number 5 from the second page of your packet, which is 2x squared minus 9 is equal to 55. Now our first step is always trying to isolate x squared. So to do that, I'm first going to add 9 to both sides of the equation. So we now have 2x squared is equal to 64. And next I'm going to then divide both sides of the equation by 2. So now I have x squared is equal to 32. So I've now isolated x squared, so I can move on to the second step. The second step is going to be taking the square root of both sides. Alright, so what's the square root of x squared? That's just x. So x is going to be equal to the square root of 32. Now it's at this point that we are going to take into account step number 3, which is simplifying the radical. So we know that x is equal to square root of 32, which is equivalent to saying that x is equal to the square root of 2 times 16, because 2 times 16 is 32. Now, the square root of 2 times 16 is likewise equivalent to the square root of 2 times 4 times 4, because 4 times 4 is 16. So now here's the general rule. If underneath your radical you have a number repeat itself, like here we have 4. So if you have any repetition here, or any pairing of a number, then you can take that number out of the radical and put it to the front, so that we know that x is equal to 4 times the square root of 2. There were two 4's, so we could take those outside of the radical and put them in front of the radical. But there is only one 2, so we had to leave 2 underneath the radical. Alright, and last but not least, remember that whenever we're taking square roots, that it's always both the positive form of that number and the negative form of that number that will serve as a root. Alright, so how would we check our answer to make sure that we got this right? Well, if we were to bring y into this equation, it would be that y is equal to 2x squared minus 64. And the roots of x, or the roots of the equation, I should say, are whatever values of x will make y equal to 0. Right. Now for x, we're going to plug in the root that we found. So we found two roots. I'm just going to put in one. I'm putting in positive 4 times the square root of 2. So we have 0 is equal to 2 times x times x. Now x is 4 times the square root of 2, so it's 2 times 4 times the square root of 2 times the square times 4 times the square root of 2 minus 64. So let's just work with that parenthetical first. Alright, that's going to simplify to 4 times 4 times 2. Because remember, the square root of 2 times the square root of 2 just is 2. So we have 4 times 4 times 2. So that parenthetical right there is ultimately going to come out to 32. So we have 0 is equal to 2 times 32 minus 64, which is just 64 minus 64, which does indeed equal 0. Alright, so if we do use positive 4 times the square root of 2 in this equation for our x value, then y will be equal to 0. So in other words, positive 4 times the square root of 2 is a root. Alright, and we could show the exact same thing if we plugged in negative 4 times the square root of 2 as well. Now, sometimes using the simple strategies we've covered so far do not work. Now, in the last resort, when trying to find roots, we can actually always fall back on what's called the quadratic formula. So this right here is the quadratic formula. Now, to know how to set this formula up, you need to always first put whatever formula you have into standard form. So here in our example formula, we have x squared plus 2x is equal to 63. Now to get this into standard form, we're going to have to subtract 63 from both sides. Alright, so we have x squared plus 2x minus 63 is equal to 0. Now we're told that in standard form, the coefficient before the x squared is a, the coefficient before the x is b, and then the number that's by itself is c. Alright, and so those are going to be, that's how we're going to know what to plug into the quadratic formula. Now in step 2, after we've gotten our formula into standard form, we're going to identify what a, b, and c are and substitute them into the formula. Right, so in this case, a is going to be 1, positive 1, b is going to be positive 2, and c is going to be negative 63. So this is what it's going to look like when we substitute those values into the quadratic formula. Now remember, in the quadratic formula, after that negative b, so in this case after negative 2, um, we have to calculate it once with a plus sign, all right, adding negative 2 to that radical, and we have to do it a second time where instead of adding the negative 2 to the radical, we subtract the negative 2 from the radical. So now in this new case, we have a minus sign in front of the radical. So we need to do both of these calculations to get our two separate roots. All right, so we've identified A, B, and C, and we've substituted them into our formula. So step 3 is just going to be to simplify. So I'm going to simplify each of the forms in turn. So let's start where we're using the plus sign instead of the minus sign. All right, so we can simplify the radical to containing 4 plus 252, which is just 256. So we know that x is going to be equal to negative 2 plus the square root of 256, all of that divided by 2. Now the square root of 256 is just going to be 16. So we know that one of our roots is just going to be negative 2 plus 16 divided by 2. That's just 7. So one of our roots is going to be 7. The other root, all of these steps are going to be the same. It's just we're going to have a minus sign before that 16. Right? So the other root then, negative 2 minus 16, that's negative 18 divided by 2. So our other root is going to be x is equal to negative 9. So our two roots are going to be 7 and negative 9. And we can verify that this is the case by using the graphing method. All right, so here I've graphed that, that equation. I've set y equal to it, and we can see that that quadratic slope intersects the x-axis, which is where y is equal to 0, whenever x is equal to, whenever x is equal to negative 9, and when x is equal to 7. Now I want to do another example because I think it'll be instructive. So let's say that this time the equation we're given is negative 2x squared plus 17 is equal to 8x minus 1. Now first step, whenever you're using the quadratic formula, is to always get our equation into standard form. So here I've moved all of the values onto one side with leaving 0 on the other. So once we have it in standard form, we then need to go and identify our A, our B, and our C. So our A in this case is going to be negative 2, our B is going to be negative 8, and our C is going to be positive 18. After we know our A, B, and C, we can just plug them into our quadratic formula. All right, so here is our quadratic formula. Now I'm just going to go ahead and plug those in at this point. All right, I highly recommend using the parentheses the way I'm doing, just so that you can make sure that you don't make any simple little mistake. So like for example, plug in parentheses a negative 8 at the very beginning, so that you know that the beginning actually starts off with a negative 8, which is just to say a positive 8, as we'll see. All right, so we've plugged in our values into the formula. Now all that's left to do is simplify. All right, so as I was just saying, we have a positive 8 right at the beginning. We have a negative 4 in the denominator. And then in the radical, it's going to simplify to 64 plus 144, or in other words, 8 plus or minus the square root of 208, all divided by negative 4. Now at this point, we want to ask ourselves if we can simplify that square root of 208 to any degree. Now on the next slide, I'm actually going to go over just simple examples of simplifying square roots. But again, I'm going to kind of walk through how to do this one right here as well. So an easy way to think about how to simplify this one is to realize that 208 is equal to 16 times 13, which means that we can actually just put that in the square root sign. Now, of course, 16 is just equal to 4 times 4, so we can actually replace it even further like that. So we have 8 plus or minus the square root of 4 times 13 divided by negative 4. Now, if you have two numbers that can pair with each other the way that these 4's are, then you can just drag those outside of the radical and put them right in front of it. Alright, so what we're left with is x is equal to 8 plus or minus 4 times the square root of 13, all divided by negative 4. So we're almost done at this point. Remember that whenever you have a complex fraction the way we do here, you can actually break it up into simple fractions. So in this way we would just divide 8 by negative 4 and 4 times the square root of 13 by negative 4. And so our roots for x are just going to be negative 2, because 8 divided by negative 4 is negative 2, plus or minus the square root of 13, because those 4's cancel each other out at that point. All right, now, this is our final answer. If you cannot simplify a radical, do not give me a decimal approximation. Give me what the actual radical is, the furthest simplified that we can get it. On this slide, I just want to quickly go through some examples of simplifying square roots. So first, if you ever have a square root of a fraction, as we have in number 1, and by the way, on the first page of your packet, this is going to be problem number 4. All right, in problem number 4, we have the square root of 4 over 9. Now we can break that up into two square roots, namely the square root of 4 over the square root of 9. Now what's the square root of 4? Well, that's 2. What's the square root of 9? That's 3. So the answer to the square root of 4 over 9 is just 2 over 3. Now remember, I don't have it here, but with the square root, it's always going to be plus or minus. So one of the square roots of 4 over 9 is positive 2 over 3, and the other square root of 4 over 9 is negative 2 over 3. All right, let's look at number 2. And in your packet on page 1, this is actually number 11. We have the square root of 250. Now we can rewrite that as the square root of 25 times 10, because 25 times 10 is equal to 250. And we can break those two numbers, 25 and 10, further down into 5 times 5 times 5 times 2. Now we do have two 5's that can pair up with each other. So those two 5's are then going to, we can take those outside of the radical. So that's why I have 1 5 outside of the radical in the final answer. Now, that third 5, because it has no partner to pair up with, has to stay under the radical. So staying under the radical is going to be one of the 5's, and that 2. 5 times 2 is 10. So our ultimate answer is going to be plus or minus 5 times the square root of 10. All right, and just one more, if we're looking at number 3. In your packet, this is actually going to be number 9. We have 5 times the square root of 72. Now, 72 is the same as 36 times 2, so we can rewrite that square root in that way. 36 is equal to 6 times 6. So we have two numbers that can pair up with each other here. All right, those two 6's. So we're going to be able to bring those two outside of the radical as a single 6. So we bring out a single 6, we multiply it times that 5 that's in front of it, and we have to leave the 2 inside of the radical because it has no partner. So our ultimate answer is going to be plus or minus 30 times the square root of 2.